Race conditions are a vulnerability class that is honestly very close to my heart. And it was my first 4-figure bounty, and it really showed me that bug bounty was something that was worth getting into and was worth investing the time to develop the skill in. And also, it was the first video on this YouTube channel, which is honestly really cool looking back. So today I wanted to revisit it again, looking at two reports, one from Google CloudBuild and one from Amazon Workspaces. I'm very excited, so we'll go straight into the report now, starting with Google CloudBuild. So what is Google CloudBuild? It's basically very similar to the thing I covered last time on the Hacktivity Explained, which is Amazon CloudBuild. It's a tool for building pull requests on your server to make sure they work and running unit tests on them and this kind of thing. So if you don't know, the way a pull request works is if you have a repository on GitHub or GitLab or whatever, someone can fork that repository. So they can basically take it and copy it over, and then they can make changes to that repository, and then they can create a pull request to the original repository, basically tell the owner, hey, can you add the changes that I made from the forked repository to the old repository, basically merging it together. And the way these tools like CloudBuild and CodeBuild work is that they look at the pull request that you've just created and they basically build it. They run tests on it to make sure it's good, and then they tell the developers, okay, this pull request was working, it passed all these unit tests, so then you can consider merging it now into the public repository. They basically help developers kind of automate a lot of this manual stuff, like reviewing the code themselves and running these tests, by making it just automatic. And especially for big public repositories, this stuff is very helpful. But as always, the main issue with these code build tools is that it's basically like RCE as a service, right? Because it's going to take the pull request and just run it on your server, which isn't great because these tools usually need some kind of credentials, especially if the repository isn't public, but it's like semi-public. It's kind of like an enterprise type repository where developers can make pull requests. These tools are usually going to need credentials inside of them. And so, as I mentioned with the code build issue, usually those credentials are on the server. So when you run the pull request, if there's malicious code, those credentials can get leaked. So this is the issue, and there's ways to basically prevent this from happening. So in terms of CloudBuild, what has to happen is, in terms of the specific mode anyway, you can disable this or whatever. But in terms of like enterprise software, there's some feature where whenever someone makes a pull request, it basically opens like an issue on top of it, like a pull request tab, and then you can comment on it and put changes in it or whatever. But for the build to be executed, one of the developers or the maintainers of the repository has to comment like a specific phrase. So there, in terms of Google CloudBuild, it's /GCBRUN. And when Google CloudBuild detects that the developers have commented this, it will pull the pull request onto the server and then build it automatically. So this is basically a way for the developers to first review the code before letting it get pushed straight to CloudBuild. And the way this usually works is with like GitHub apps. So there's usually a webhook behind it that the CloudBuild is listening for, and GitHub is sending information across it. Now, just for later, these webhooks tend to be a little bit slow. There tends to be delays on them. So remember that it tends to be a little bit delayed because GitHub has to process it, then it has to send the webhook via HTTP, and then CloudBuild has to process it and do a lot of things with it, so it can get a bit delayed. Now, the vulnerability here was actually really simple if you think about it. Let's say we created our own repository and we forked the repository and created a pull request. Let's say it was just benign code, it was clean and empty code. When the developer comments the phrase to create the build, there's a time between when the Google Cloud Build receives that comment and when the repository can change. So that time is usually pretty low, but that time does create a race condition. So let's say this attack. You are a developer and you've just reviewed a pull request. It's fine, it's good, and it's basically like exactly what you want. So you commit the build in order to build it and see if everything's running. Between the time that you sent the comment and GitHub Cloud basically processing it, the repository could change. Let's say you quitted the comment and the attacker set up a listener themselves, so that as soon as you comment it, they change the repository to some kind of malicious code. In that time, Google Cloud Build, when it receives the comment, it will actually pull the malicious repository instead of the one that you reviewed. And that was basically the whole vulnerability. So it was the classic time of check, time of use, race condition vulnerability. And I thought that this was very cool, honestly, because just the simplicity of it and also the impact of it is pretty big. So this is kind of what the author here showed us, this kind of diagram, where basically you'd create the pull request, you'd basically set up this listener, the maintainer will review the code or comment, the attacker system will pick up that comment, they'll modify basically the configuration file, they'll modify the repository, and then CloudBuild will pull that repository via this SHA, and then it will build it. So that's the whole attack pattern. I thought that was pretty cool race condition. Honestly, a lot of these race conditions are kind of a lot about thinking than really most technical things. You just have to kind of think outside the box for them. That's kind of what I liked. And yeah, he managed to demonstrate that he could get RC on these repositories, and he got $30,000 off this from Google, which is very cool. He mentioned here that it's probably because Google has public repositories that use CloudBuild, so it also could have affected Google in a lot of ways. And they basically decided to give him 30,000, which was a very good bounty, and for something that was fairly simple anyway. The fix was apparently a 5 seconds old. So it basically has to be 5 seconds old between the comments. So they basically check the time that the comment was made and when the latest build was to basically prevent the vulnerabilities. That was a very cool report and I really enjoyed reading that. And yeah, I recommend you have a read of it as well. It's in the description. But we're going to move on to the next report, which is in Amazon Workspaces. So what is Amazon Workspaces? Amazon Workspaces is this tool where basically enterprises can give their employees these kind of remote desktops they can connect to on a single instance. Now this is hosted personally. So this is not hosted on Amazon, but it's hosted by the company. So they will give you like this server configuration and stuff and you'll host it. And then what you can do is you can basically create these like remote desktops that your developers can connect to, or developers or employees or whatever. But the only very annoying thing is that it runs on Windows. I hate Windows vulnerabilities, but anyway, we're going to try and see through this together. But yeah, it creates these Windows desktops basically. And because this is a single instance, you basically need to have the users as low privileged users in the machines on Windows. And you don't want them to get system permissions. So on Linux, it's like root. On Windows, it's this NT authority / system type thing. So that basically means root on Linux. So we don't want the users to have root because then they could access other users' desktops and basically control the instance. So we at all costs want to prevent that. So we need to prevent privilege escalations, which is what we were targeting here basically. So this is basically the flow here. So on this system, every desktop had kind of logging endpoints. This is pretty common in enterprises. They want to log reports and send it to the enterprise instance. Maybe this is for Amazon as well or whatever. So the enterprise people can spy on you basically. That's what this is for. And in this case, it was stored in this directory. It was in C program data Amazon /Skylight Metrics agent. And inside this folder, there was 3 other folders. So there was a folder called current, which were the reports that were currently being gathered by Amazon. They were being stored in this folder. Then there was a folder called rotate, which was for archived reports. Once a report was archived, it was put in this rotate folder. And then as soon as it was put in this rotate folder and verified, it would be put in this transmitted folder, which I imagine it was like sent off to Amazon or whatever. It would be put in this transmitted folder and there'll be data attached to it. It's pretty common use of these folder systems because companies like logging and they like having archived logs and like this data collection and this classic thing. So they like having this data collection set up. But there's a few notable things about this. One, the low privileged user controls this data themselves. So this Skylight Metrics agent folder is available to the user because it's being collected on their own instance. So this folder is accessible to the user. And remember, because this is an instance, the attacker here was doing code review on this. So we can see a bit of the code that was coming on here. And basically, when a log was created in the current directory, so any type of log, it would be moved to the next directory, it would have a date attached to it, then moved to transmitted. So you can see exactly how this works here. And basically this creates the directories if they are missing, whatever, if they're not directories there, it creates them already. Then it will basically enumerate the entire files in the current directory. Then it will move the files over to archive with this kind of folder here, and then it will basically move it. Phenomenal. File.move is basically the standard one. I think this is written in, it looks like Java or something, I'm not sure. Anyway, once this was moved to the archive directory, the second bit of code kicks in here, which basically, all of those is basically just checks if the file exists. So for every file, it checks if it exists in the directory, and then it basically just moves it, plus it appends the transmitted time for the file basically. So what could go wrong? Well, you can think of a few things now, and the main culprit here was symlinks, as I'll always anyway. So what is a symlink? So symlink is basically a pointer to another file on the system, and it's just the biggest pain for anyone that's trying to design anything security based, because it just causes all sorts of issues with symlinks. And apparently, I didn't even know, but this actually exists on Windows as well. And on Windows, it's called a junction. So instead of being a symlink, it's called a junction, but it basically functions the same way. And because we control this report directory, and because the logging system runs as system, what we can do is we can basically trick the logging system to move the file from the current directory into a directory that we control, which is actually symlinked to a different directory on the root file system. And because of the way that writing files and stuff works on these file systems, once you have write access to these root file systems, you can write any file. More often than not, on outside of like very minimal containers, you can actually escalate to root because you can override some kind of file that the system is going to use later. The classic one on like Linux is you can add like a cron job, which will just run like every once in a while, and basically it will run as root because root created it, which is exactly what we want. So it'll give us execution through that. And that's basically what allows you to basically promote yourself to the root privileges. And what was the race condition here? Well, the race condition is actually in order to prevent the file from being modified after we've created it. So let's look at this diagram now. So once the system moves the file into the rotate symlink that we created, it will try and basically move it to the transmitted folder after, but we don't want to do that. We need to delete that folder. We need to delete like the symlink so that the files cannot be modified after they're moved into that directory. And we can do this by just basically racing it, and we can just create a system basically that will just log it for us and then delete it immediately. So that was the kind of the race condition there. And once the symlink didn't exist, the Amazon would just error, and then it would not do anything. So the file would just stay in there and it would get automatically executed. So that was a very cool privilege escalation using a bit of race conditions there as well. And yeah, honestly, I also really enjoyed this report, and this is very recent as well. Don't know how much they got paid for this, but it was definitely pretty high severity considering that you could basically get privilege escalation on this enterprise instances. And yeah, I hope you enjoyed this video covering these two race condition reports. And honestly, I really enjoyed it. Race conditions are one of my favorite vulnerability classes, and I honestly should talk about them more on the channel. They pay very well. They're quite lucrative in other places, especially these Linux privilege escalations. You can see like a lot of the Linux privilege escalations, if you go back over the CVEs, a lot of them are just race conditions basically. They're like race writes or reads basically. And this just shows you how hard it is for these security developers to basically visualize these race conditions to predict how data is going to change over time. And it's even harder for these LLM models because, you know, they see these perfectly working code, you know, they write it perfectly, but it's hard for them to predict how this data is going to change and how the user can manipulate it, especially over a quick interval of time. So I think it's a very good vulnerability class to get into, to start looking for, and to basically start working into your hacking game. And yeah, if you did enjoy the video, please do leave a like and subscribe to the channel so you get more bug bounty content recommended to you by the algorithm, so you get that edge over the competition and you will be able to find your next bug faster. That's it for me. Thanks for watching and happy hunting.